everyone, welcome back to my YouTube channel. This is Kirtana, currently pursuing my second year BE in Electronics and Communication at Sri Venkateshwara College of Engineering, Bangalore. Today I am back here with the subject Network Analysis and the subject code is BEC 304 and the topic is Mesh Analysis. So I'll be explaining mesh analysis with two example problems. So first, let's look into the introduction to mesh analysis. Mesh analysis is a systematic method for analyzing electrical circuits. It is based on Kirchhoff's voltage law, that is KVL, which states that the sum of voltages around any closed loop must be equal to 0. This technique is especially useful for planar circuits where the number of meshes is less than the number of nodes. So here in the attached figure we can identify two meshes, that is mesh 1 and mesh 2. Before moving on to the key concepts, I need to give a small point, that is mesh analysis is also called as loop analysis. Now looking into the key concepts in mesh analysis, a mesh is a loop in a circuit that does not contain any other loops within it. Mesh currents are hypothetical currents that flow around the mesh loops in the circuit. The objective is to write KVL equations for each mesh in the circuit to find the mesh currents. Now let's look into the steps for mesh analysis. Identify all the meshes within the circuit and assign mesh currents to each. So whenever a circuit is given, first we need to identify all the meshes and we need to name all the mesh currents in the circuit. Then apply KVL to each mesh, writing equations based on the voltage drops and gains around the loop. Solve the resulting system of equations to find the mesh currents. So here in the attached figure, it is just a small example problem. So first, there are three loops, that is loop 1, loop 2 and loop 3. So the current flowing through all these loops is I1, I2 and I3. When we calculate KVL across mesh 1, it gives minus Vs plus V21 plus V23, that is Vz3 is equals to 0. Similarly, we can apply KVL for mesh 2 and mesh 3 also. Now let's look into the example problems overview. We will analyze a simple circuit with meshes and several resistors and voltage sources. So before solving problem, we'll just have a glance what are we are going to solve in the problems. So first we'll analyze the circuit, divide them into meshes, that is identification of meshes. This example will illustrate how to set up KVL equations for each mesh. And after deriving the equations, we will solve for the mesh currents. Now let's look into the circuit diagram for example problem 1. The circuit contains three meshes with resistors and voltage source. The mesh currents are denoted as I1 for the first mesh and I2 for the second mesh and I3 for the third mesh. Resistor values and voltage sources is specified in the circuit diagram. So have a look at the circuit diagram. We'll be solving the problem in the next slide. So the question is, find the current through 2 ohm resistor using mesh analysis. So here we have 3 loops or meshes, loop 1, loop 2, loop 3. Now applying KVL for loop 1, we'll get 10 minus 6i1 minus 1 into i1 minus i2 is equals to 0. When solving this equation, we'll get minus 7i1 plus i2 is equals to minus 10. Consider this as equation number 1. Now apply KVL for loop 2. Applying KVL will get minus 1 i2 minus i1 minus 2i2 minus 3i2 minus i3 is equals to 0. On solving this, we'll get minus 6i2 plus i1 plus 3i3 is equals to 0, which is considered as equation 2. Now apply KVL for loop 3. That is minus 10i3 minus 20 minus 3i3 minus i2 is equals to 0. On further simplification, we'll get 3i2 minus 13i3 is equal to 20, which is considered as equation 3. Solving all these three equations, that is 1, 2 and 3, we'll get I1, I2 and I3 values, that is the current across the loop 1, loop 2 and loop 3 values. I1 is 1.34 ampere, I2 is minus 0.61 ampere, I3 is minus 1.680 ampere. All these values we can get by using a calculator. By substituting all these three equations in a calculator, we'll get I1, I2 and I3 values. Now let's look into second problem. Before moving on to the problem, we'll just have an overview of it. So the second example will involve a more complex circuit with 3 meshes. We will analyze how to set up the KVL equations for this circuit. The goal is to derive and solve the mesh currents efficiently. So this is the circuit diagram for the second problem. Now let's apply KVL for loop 1. It becomes 5 minus 10i1 minus 2 into i1 minus i2 is equals to 0. Here we have used i1 minus i2 because the resistor is shared between both the loop 1 and 2. On solving this equation, we'll get minus 12i1 plus 2i2 is equals to minus 5. Consider this as equation 1. Now applying KVL for loop 2, it is minus 10i2 minus 2i2 minus i3 minus 2i2 minus i1 minus 20i2 is equals to 0. On further simplification, we'll get 2i1 minus 34i2 plus 2i3 is equals to 0. Consider it as equation 2. Now applying KVL for loop 3, it becomes 2i2 minus 12i3 is equals to minus 10. Consider it as equation 3. As I have told in the previous problem, substituting all these three equations in the calculator, we get the current flowing through loop 1, loop 2, loop 3, that is I1, I2 and I3. So I1 is 0.42 ampere, I2 is 0.075 ampere, I3 is 0.895 ampere and I1 is 0.42 ampere. Since in the circuit it is given 2R, we need to find the voltage across the 2 ohm resistor. As we all know, according to Ohm's law, V is equals to I into R. So here we have considered I as I2 minus I3 because it is shared between loop 2 and loop 3. And substituting all these values, we'll get minus 1.54 volts. That is, voltage across 2 ohm resistor is minus 1.54 volts. Looking into the conclusion, mesh analysis is a powerful tool for analyzing DC circuits. It involves dividing the circuit into meshes and assigning current variables to each mesh, writing KVL equations for each mesh, and solving them simultaneously to obtain the mesh currents. Thank you for watching. Please do like, share and subscribe my channel.